explain about my code and how I'm like about what deal with about the traffic light solution in here. So let's go straight to. So you can see in here the first thing I create about the file this file to in order to like to store about the data. The first thing I got like about three column, which is the first thing were like about the I'm starting about the timestamp, which include about the day and the time of that thing, and also like about the light like traffic light ID, and also like about the number of car count, number of car count. So you can see in here it's got like about the different time in here, which is, and also like about a different light ID in here at a different area. So let's just go back to our code. So you can see in here I'm implement a lot of the library, external library. The first thing was like I'm creating about a queue in to storing about the data stream, and also like about maps to store the number of car at each traffic light, which is because like we already create about a queue in to store that thing. I also want to like about map testing to store the number of car at each traffic light in order to like when you are taking that one in order to calculate it, it's much more easier. And also like about create about the I want to like make it like about I want to start about the priority queue to maintain the list of the most constructive slide. So which mean like like about the traffic light ID, which have the most vehicle count will be on the top, and yeah, and the lowest one will be at the bottoms. And I'm also create about the mutex in order to ensure about the flow safety. Like about you already know, like in the I want to like prevent about a lot of access enter at the same time. So for example, like about I need to like one access at a time. I don't want like a lot of access going at the same time because it will make about the bottlenecks and the conflict between the data. So yeah, so that's the reason why I'm using about the mood settings here, and I'm also like create about a condition variable to synchronize between the graphs because like I want to like make it like I don't want to like wasting a lot of the time, and also like the like wasting a lot of time, and also like a lot of environment, a lot of data environment. So that's the reason why I put it in here in order to like I don't want to it always checking about the new data whether it have a new data or not. I just set it like about waiting. It's just waiting until like about we have a new message. I don't want it to like just go into this data set, to checking every time. I just wanted to wait until like about we notify that thing we have a new data, and then just go inside the data set, and then taking like updating it. And also I'm create about a flag to like indicate when the data reading is complete. And the next thing I'm create about the function producer. Like producer will like which will be like about reading data, the data from the file, and then push to the data queue. So the producer was like about, for example, just like about our things. It's me. It's like sending order, like sending a message to like another thing, like about sending a message to the teacher, like about I want to submit for the assignment. So like I will be the producer to like send a request to the teacher, and the teacher will be like the consumer, which he receive my message about that thing. So we got like about the people at the main, which is the algorithm, for example, like about you will got like when you're sending a message, you will got like about a third party, which is our computer, in order to send it to the consumer, which is the teacher. So the producer and consumer in that case is similar to the example I have been mentioned. Producer is me, and the consumer is the teacher, and the third party our computer. We just send a message in something like that. So the go back to the code. So producer function is just like read data from file and put the stream to the data queue, and then I'm also like create about the debug of if else in order to checking whether the file is open or not, and is how we reading successfully or not, and then I'm reaching each line from the line and push to the data queue. And then I'm using about the mood stack to ensure the rest safety when setting the queue, and then I'm use the condition variable to notify the consumer rate. And then when everything is finished, like every action is finished, I'm just set it done, set the flag is true, and then notify to all, like, and it notify to the consumer rate to notify is okay, everything is finished. And yeah, and the next thing will like I'm great about the function consumer to like receiving a data from the data queue and then update the number of car this traffic light. So you can see like there are a lot of number of car at each traffic ID, which is some of them might be the same, some of them might not. So yeah, so the consumer will like grab everything up and then calculating it. The yeah, and then I wait until there is the data in the queue or the data reading is complete. When everything is complete, I'm just using the get line to analyze about the data stream, and then I'm update that thing at the traffic light in the traffic count mapped. And then if everything is got error, I'm just like showing the error in here. And then I maintain a list of the most contractive light in the top traffic stripe that already queue. So which I'm already explaining it in here. And let's go to our main function in here to initialize the MPI. The team determine the role of the process, which is the master and the slave. And the first thing, of course, I need to like initialize the MPI and getting the rank of the process. And the next thing, like I'm create about the number of the most congested traffic light to print. So which is I'm set it to 10, which is it will show like about the top 10 traffic light, top 10 congested traffic light. And then I'm setting like about this thing was like I'm calling in a master brain, which is if the rank is 0, which is our master, it will create and run the reducer and the consumer rest. So in here I'm just like reading from the traffic light, which is traffic data of TST reducer, and then consumer will take in that one and checking if it like if that thing were the traffic light is not empty, which is not new, it will like showing us like the traffic light and the number of cars, that's one. And otherwise if the man is not working, or maybe like the man is like about suddenly shut down, it will just go into like a process of the sled, like it exactly just like showing the performing about the same consumer, but like it's working on another device, not like in the main device. So yeah, everything will be the same in here, and then when everything is finished, it will finalizing it using the MPI, and MPI complete finish. So let me just show you about the output. Okay. So you can see in here we got like about traffic light ID 1, it having the card 50, which is the largest one, and then you already know we just started on a queue, so priority queue. So that's the reason why we are just those who have the highest will be on the top, and those who is low will be at the bottom in here. And in here you can also see like there are a lot of car and it's like a different time, and also like at a different ID at the different at a different time. They also got about a different number of car, but like when you are showing the output in here, it just like calculate the sum of it. So yeah, thank you.